Tonight's project, contactor. So if you don't know anything about them, this is line 1, line 2. This is where the power comes back out for line 1 and line 2. It's T1, T2. When the contactor closes, it energizes through these contacts. So you got your power coming in, contact closes, power is now going out. When it kicks back up, it breaks that power in here, and this side's now dead. What causes them to close? This is your low voltage side. So you may have 240, 480, whatever up here, depending on what your contactor is, what you're trying to wire, and what it's rated for. So you run your high voltages up here, your low voltage down here. It tells you on the contactor what it takes. So most of the time you got like 110 here, one coming in, one going out. You may have 220, two legs of 220 going in to start a motor or whatever. So from the small control board, you have 110 or whatever. Just depends on what it's set up for. But your low voltage comes in here, will probably come in off of a switch. It could be a computer relay telling it what to do when, we'll say, it hits 120 degrees, the water level does. This contactor is supposed to close and pump and circulate that water to help cool it back down. So that computer, that relay, kicks on right here, energizes the circuit that's inside, makes the contactor close because it magnifies, it makes a magnet effect in here and pulls that contactor down, and that that runs the high voltage. So that's how you have control voltages that run high voltages. It's not, that same voltage is not in those controls. It's run by low voltage, and the low voltage controls stuff like this to run the high voltage. So this is motor control stuff. It's a contactor. It's actually a Cutler hammer. Gives you horsepower rating, voltages. I mean, your voltages, it can run 115, 230, 460, or 575. So basically that's about it. Just give you an idea of what these are. They're normally mounted on a wall or something like this inside of a panel. Those relays do go bad in there, different things, so you can easily replace them by taking the screws out, pulling it out, putting another one in, and you're good to go. So again, low voltage side right here, turns on the relay and closes, finishes that electricity through here to run whatever it is you want to run. So y'all hang tight, we'll be back with you in a second, and we will see what it looks like inside.
Rock bottle on the track, boy.
Alright, so off the top up here, I've already taken these three out. I've got one left. So you spin it out counterclockwise. Most of the time, right there, see it stops. If you put a little bit more pressure on it, it'll come on out. That's just kind of a safety feature to keep them from backing out and the screws falling out and all. Once you get it backed out, you pull this stuff out. All this is brass, so it has to be kept a little separate. Your low voltage side, I already took one out, and again this is brass, so you take the other one out. the screws are out. As you can see, this is copper in here, top and bottom. I think you can see that beautiful copper color. That's going to be steel. Now, I've never taken one apart before. I know what they are and what they do, but kind of new to me on the scrapping thing here. So I'm going to say we can probably push right in. Right there. Get something a little bit smaller. And I'll put the bigger one in. Bend it out a little bit. Get to the other one. Do the same thing. So on that side, basically, I just took the small flat screwdriver, pushed it in like that, just to make a spot. Put the big screwdriver in or pried it on back so it doesn't fall back into the lock position. So it's ready to fall out, but I'm just trying to show y'all so you can see. You're going to take this contactor and then lift it up on it. So, spring loaded. That's what pushes it, keeps it held up when it's not engaged. Here's your actual contacts that closes everything. Or, I'm sorry. When this coil on the bottom here becomes magnetized, that pulls that contactor down to make contact. So this is your low voltage coil on the bottom from these screws. When you run the voltage through it, it becomes magnetized. It pulls this piece right here that moves. So the spring keeps it in the up position. And when it becomes magnetized, it comes down. Doesn't go far. It becomes magnetized to this setup here, which is inside. So it pulls it down and it hits that and stops. And when that low voltage comes off of it, the magnetism goes away and the spring pushes it back up. So that's basically the same steel you find inside of thought I had one laying over here. Transformers and stuff like that, that laminated, you know, multiple plates put together. So on this part, you got your spring. Of course, you got your brass contacts. And this circle here, this can be a circle of copper. So we'll get back to that. You got your bracket itself, of course. That's going to be scrap steel. That's going to go to steel. And this piece. So let's see what the easiest way to do this is. I'd like to keep it intact so y'all can see. It does not look like there's much of anything to be able to take it apart. So let's see what we can figure out without having to smash it with a hammer. This is why safety glasses are important. But if you're anything like most of us, you hate them. So I think what I'm going to do is bring y'all back once I get this taken apart. This very well might take me a few minutes. As I said, I ain't really fooled with one in a while, so I will be back with you all here in just a minute. Alright, so basically the inside of the top part that closes the legs looks like this. So you've got a spring on the bottom side that's always holding it up. And I done broke a piece off, but there's a spring on the top side too. So it's sitting there looking, you know, about like that. So when the contactors close, this piece comes down and it pulls this piece down to make contact, and then when it opens, when you turn that low voltage off, this comes up and opens this contact, so there's no more voltage there anymore. So it's, I mean, it's a simple, you know, mechanical switch there. So the reason for taking these apart is, if you can see on this, on both sides there's a big button on it, big square button. Those are silver, both sides. So you want that. And the same thing here, there's a button here and a button here where it closes the contacts to run it all the way through. So those are silver as well. So just kind of take them and it was loose a minute ago. Put a screwdriver under there and pry it up so it unlocks. There's your big brass contactor with a silver button on the end. This is where the screw went through, the big screw. So you want to melt the copper, you want to melt the silver off of those. So, I mean, you can take a acetylene torch or whatever, hold this side with pliers, put an acetylene torch on it, and it'll bead up and just boop, drip right off the end, and you've got it. So that's that side. This side, I'll open this in the same way. I was taking my time opening it, trying to get something so I could really show y'all what was inside of them. For anybody who didn't know how they actually work. So when you're trying to open stuff that way, it takes a little longer, a little extra effort. As you can see on this side, here's your contactor. It's normally open. You throw the low voltage on the side down here, it closes. That creates your pathway through there. Then when that switch says, okay, I'm done, it turns the voltage off down here. That magnet stops, and it goes back up, which opens the contacts. So, pretty simple design. And this is only a two-phase motor. It's not for a three-phase. because it only has contacts on the on the outside spots. It doesn't have it in the center. So there it is. It's nice and open now. So that spring on the bottom stays open when that contactor turns on. The low voltage, it pulls a magnetic field. It grabs that metal and pulls it down, and it makes contact just like that with the other two. And then after, when that low voltage turns off, the magnetism goes away. It kicks back up and turns it off. Super simple. So I'm going to finish cutting this out and I'll bring y'all back to show you the contacts. Alright, looking at it from the bottom. It's the top, it's the side. It's a piece that carries everything. Contactors through that. So you got some decent metal here. Heavy duty metal. Contactor itself actually goes that way. This is what the magnetic field wraps around this and spools up, turns this into a magnet and pulls that bottom piece down. That in turn pulls this contactor down. So if you ever need to know anything about that, if you have more questions, let me know. As you can tell, that side's black, super dirty. So this side's burnt. And I mean, those silver plates wear down, you know, over time. The more it turns on and turns off. I mean, even this piece of that contactor is nasty, dark, dirty, black. But that's all your brass. It's quite a bit of weight. I mean, you can definitely tell you got it. And you got those silver contacts you can melt right off of there. So I'm gonna see if I can open this without tearing it up so y'all can see what that looks like as well. So I'll bring y'all back in a second. Alright, so I got it cleaned up a little bit, but you can see the brass right there. That's where the screws were, where I grabbed them and twisted them off. They're right here, chasing the camera. You can tell that's a coil. I mean, that's a coil of copper. If you're holding it, you could tell there's some weight there. But yeah, that's what the two screws were that I grabbed and twisted and broke off. You can tell that's, you know. So I'm gonna see if I can't run this outside, because I don't think this is gonna work. But I can probably run this outside. Smack her with a hammer once and she'll come right apart. So I just pulled, you know, those off. You see brass on both sides. That's where your voltage went in and out. Come from right here. What's the easiest way to open these? Roll it up in a towel and smack it with a hammer once or twice. Drive over it with a truck, something like that, and just pick the pieces out. I'm trying to do it this way for y'all's benefit so you can see how stuff works. So, but I'm gonna have to hit that with a hammer. It's too hard to cut open with the hand tools I got. So I'll be back in a minute. Alright, so I took her outside, turned her up on her side, basically so it looked kind of like that. Smacked it twice with a hammer and pieces started flying everywhere. That's when you know you're doing a good job. And you're scrapping stuff and pieces are flying everywhere. Getting something accomplished that way. Let's see if I can get this off. So y'all can see it a little bit better. There it is. So this is actually like, this plastic is poured. I don't know if y'all can see the grooves in there, how rough it is, but it's poured in around this copper coil, so it sticks to it, you know. And as you can see, there's copper, quite a bit of copper. We want to see how much copper, and we can. if I can finish getting the rest of this off of it. 'Cause it's stuck to it. There we go. So I've got a little bit left up here. Kind of goes down through it, if I can get it to twist out. There it goes. And you got a nice ball of copper there. You don't have to ball it up, you don't have to unball it, you don't have to do nothing. So let's see what the weight is. So we end up with a pretty good amount of scrap steel, heavy scrap steel, brass, and a coil of copper. This is set in pounds. Alright, so we're looking at 1.6 ounces. So an ounce and a half of copper. I mean, if you want to pull it apart, you know. Ooh, it looks. But yeah, I mean, you can definitely tell. Measure again. 1.6. So I mean, that's not bad. Doing steel weight, 7.5 ounces. All this brass, I think those screws are white brass. I'll have to test them to be positive, but it's only 2 of them. But you're looking at 0.8 ounces of brass. Of course, you can clean this up and put that on there too. So that puts you at 0.9 to an ounce of brass. So not a bad item to tear apart. Of course, you don't want to take a half hour like I just did. You want to do it fast. So smack that thing a couple times with a hammer and let the pieces fly, and then just pick everything out of it. And you know, it's a pretty good amount. Decent reward for time. But alright, well, I guess that's pretty much it for this video. Just want to show that to y'all, something a little different. That's what I'm trying to do, is bring y'all all the different things I have around here, so y'all can see different things that you can pick up, look for, take apart, what's in them, that kind of thing. So catch y'all next time. Have a good one.